And let us discuss the next problem. This is a pretty easy problem. So 1.62. I think all of you can do this problem. So there is an inclined plane and the angle is given to alpha. So the question says a small object was launched up an inclined plane against a horizontal with makes angle alpha. So there is an object that is launched up along the inclined plane. Find the friction of coefficient. So we have to find mu. If the time of ascent is 2 times less than the time of descent. So let us say time of ascent is eta times less than the time of descent. So time of ascent is equals to time of descent less than d. Eta times less than. So time of ascent is equals to time of descent divided by eta. So let us say TA is equals to TD by eta. So we have been given one expression, that is TA by TD is equals to 1 by eta. So this expression is given to you. So can you find this one? How can you do this one? Why there is a different time? So this means this object goes up and then comes down. Why there is a different time? Can anybody tell me why there is a different time? Why not this time, the time to go up is equals to time to come down? So this point it goes somewhere here and then come down. Why not these two times are same? Can anybody tell me? Yeah, this is because of the friction forces and mg. So you see, when this is going up, mg sin alpha is coming down and friction force is also coming down. But when this is coming up, so let us say fast, let us say ascent journey. So what is the time of ascent? So when this is going up, I can write what the forces that is acting on the object. Mg sin alpha is acting downward and friction force that is acting up, and you know this is mg cos alpha is the normal reaction times mu, that is the force of friction. So what is the deceleration, or you can say deceleration of this block is will be mg sin alpha minus mu mg cos alpha divided by m. So this is the deceleration. Are you getting? So you will have basically deceleration is g sin alpha minus mu cos alpha. So what is the time of ascent you will have? So let us apply v square minus u square is equals to 2as, but u is not given to you. So initially u that is not given to you. So how will you solve? Initially u is not given. So let us assume initially it has been thrown with velocity v0, and later we will see we have to have cancel out this v0. So let us say what will be the time of flight. In this case we will have initial velocity is v0. I can apply s is equals to et plus half at square. So let us say this goes up to a distance s. So I can say s is equals to ut. So v0 into t minus half at square. So g sin alpha minus mu cos alpha t square. Why we have taken minus sign? Because this is a deceleration. Object is going up. We have found what is the total acceleration in the downward direction. That is the negative basically. So this is the deceleration. This is not acceleration. So this is a deceleration, and that's why we have given a minus sign here. So from here I can find time of ascent. So let us call this the time of ascent. Now so let us discuss descent. So this is the equation of ascent. So this object, when this object is coming down, what is the acceleration? So now what are the forces that is acting on this object? So this is coming down, so it will have m1g sine alpha. So mg sine alpha, no m1. So simply let us say this force downward acting is mg sine alpha. Friction force again is coming downward. So in the previous case friction force will be downward because this object is going up. If this object is going up, so this means the friction force has the tendency to decrease the motion. So friction force will be downward direction. So this is not up. So this is down basically. You're getting? So this friction force will act in the downward direction. So this m1g sine alpha plus mu mg. So this will be plus. So everywhere you will have plus. You're getting? Now in this case, this is coming up, going down. This is a descent. So friction force will act up. So mu mg cos alpha. So this is cos alpha. You will have mu mg cos alpha. You're getting? In this time, this acceleration will be. This time this system will accelerate because finally it will go and it will end up to the final point. Acceleration will be, velocity will be 0, and then it will start coming down. So acceleration in this case m1g sin alpha minus mu mg cos alpha by m. So you will have g sin alpha minus mu cos alpha. So let us say apply again time of descent. So distance will be same. S is equals to, now initial velocity is 0 because when it reaches up to the top point it becomes rest and then start coming down. So S is equals to ut plus half at square. Now this is acceleration this time. So u half a g sin alpha minus mu cos alpha t ds square. You're getting? So you will have t ds square. Now we want to solve for, now these two distances are basically equal. So S from equation 1 and S from equation 2 must be equal. So I can write S from equation 1 is V naught TA minus half Z sin alpha plus mu cos alpha into TA whole square. You're getting or not? So you check your equation. This is here V naught TA minus half this one equation. So you see this is equals to half Z and sin alpha minus mu cos alpha into TD square. So if I equate these two distances I will have this equation. Now I have to eliminate V naught also. So what can I do to eliminate V naught? So you see, if you see the previous journey, the ascent journey, it has been thrown with velocity V naught, and after traveling distance S, the final velocity becomes 0. So I can also apply, and the acceleration in this case is basically deceleration, downward acceleration you have. That is g sin alpha plus mu cos alpha. You check your copy, you will get the same thing. G sin alpha plus mu cos alpha. So I can also apply one equation, v square minus u square is equals to 2as. So v square is 0 square minus u square is equals to 2. Acceleration is basically deceleration, so I have to apply minus 2z sin alpha plus mu cos alpha 2as. So distance is s. So I can eliminate s. So from here I can write v naught square is equals to 2z sin alpha plus mu cos alpha into s. So basically I have to eliminate v naught into t. So any other equation I can write v is equals to u plus at, if I have used v is equals to u plus at, maybe that case I have got a good result. So let us apply the next equation. So let us call this equation, if I apply v is equals to u plus at, so final velocity is 0, v is equals to u v naught plus at. So acceleration is this, so g sine alpha plus mu cos alpha a into t, and time of ascent is t. So v is equals to u plus at if you apply. So from here I will get v naught is nothing but g sine alpha plus mu cos alpha into ta. Are you getting? So let us copy this one. So from this equation, equation number 4, let us call this, I can put the value of v naught in equation this one. So this equation we have, I can plug the value of v naught in this equation. So let us say I can plug here what is the value of v naught. So v naught is g sine alpha plus mu cos alpha into ta. This is your v naught. Are you getting? And now this is v naught times ta, so ta whole square you will have, minus, you check your copy, you will get the same thing, minus, you see half z this into ta square, so minus half z, same thing, sine alpha plus mu cos alpha into ta whole square, and this side you will have half z, only thing here will have a minus, so half z sine alpha minus mu cos alpha t d square. Now everything is simple, just I am doing the mathematics. So now this is half, 1 minus half, so half, and this half goes out, g also goes out. So I will have finally sine alpha plus mu cos alpha ta square is equals to sine alpha minus mu cos alpha td square. Now see, in the question is given ta by td is eta. So this is 1 by eta whole square. This is equals to sine alpha minus mu cos alpha divided by sine alpha plus mu cos alpha. So you can solve for mu. So from here you can solve for mu. So let us try to solve. So you have to solve for mu here. So let me solve for you. So if we multiply this side, you will have sine alpha plus mu cos alpha. This is equals to eta square sine alpha minus eta square mu cos alpha. Are you getting? Now if you take mu cos alpha common, so you will have mu cos alpha 1 plus eta square. This is equals to eta square minus 1 sine alpha. So from here you will have mu is equals to eta square minus 1 divided by eta square plus 1 sine alpha by cos alpha, that is tan alpha. Are you getting? So let us copy this one fast. So basically we can find mu using a simple experiment. So if I want to find mu on a rough surface, I can do a simple experiment. I can throw a object with velocity v naught. V naught is not necessarily known, and I can measure the angle alpha, and if I throw this object and I can find what is the time of up, that is the time of ascent, or what is the time of descent. If I know the simple ratio of time of ascent and time of descent, and if I know angle of inclination, I can find mu. So this experiment can be done in the laboratory to find the friction coefficient of any surface. You can always make any surface that is flat even. You can make inclined, so you can make a something like this roller or something you can put. so that this surface after some time gets inclined. So this is experimental setup. Even if a flat surface can be moved up and it can be made inclined. So this experimental setup can be used in the lab to find mu. So this is a one way to find mu. So just find out what is the time of flight and what is the time of descent and what is the time of ascent. You take the ratio of these times and you solve these equations. Mu is equals to eta square minus 1 by eta square plus 1 into tan alpha, and there you will get the mu value of mu. So this experiment can be done in the laboratory. There is another way to find mu, and that we do in the laboratory is we have an inclined surface, we keep an object here and we start increasing this value alpha. What happens? There is a friction force that is acting upwards, that is mu mg cos alpha, and there is a downward force that is acting mg sin alpha. Are you getting? So if you increase alpha, cos alpha goes down and what sin alpha goes increasing. So this has a tendency to come down. So this object, if you increase alpha, this object has a tendency to come down. A situation will come when mu mg cos alpha is just equals to mg sin alpha. In that case, this object will just slide. So you start increasing this alpha. So you start increasing the alpha up to the point when it just starts to slide. When just starts to slide, so when just starts sliding, when this just starts sliding, we can write mg sin alpha is equals to mu mg cos alpha. So mu mg cos alpha. Are you getting? So from there I can write tan alpha is equals to mu. So if I know the angle of inclination, what is the angle at which this starts just to slide down? That is alpha. Alpha is the angle when, so this alpha I am increasing the alpha. At 1 alpha this starts sliding. That is alpha. So just slides. In that case I can, tan alpha will give you the value of mu. So this is another base. So this is another experiment by which we can find mu. So this is a experiment that can be done in the laboratory to find mu of any surface. So let us copy these things. You can write some notes also on your copy, and then we'll discuss the next problem. So let us take some time so that you can copy this one fast. Okay, let us finish it here and then we'll discuss the next problem. I think all of you have copied this one. Easy problem. Something related to coefficient of friction, how to find out the coefficient of friction. So we have discussed two experiments. In one experiment we can throw an object up the incline, we can count what is the time of ascent, what is the time of descent, take the ratio, find the ratio, and then using the mathematics you can find the mu. Another experiment, you just keep increasing the angle of inclination and see at what inclination the object just starts sliding, and that will give you the friction coefficient. Let us go for the next problem.